Hi, Module 11 focuses on factoring polynomials. In this first section, we'll be factoring by taking out the GCF of the polynomial. Now, what's a GCF? GCF stands for greatest common factor. When we're just talking about numbers, no variables, the GCF will be the largest number that divides into two or more numbers without a remainder. So, to review this topic, here are a few examples. If I said, what is the GCF of 2 and 8? Well, the largest number that will divide into both 2 and 8 is 2. Now, of course, there are other numbers that divide into 8, not 2. 2 is a prime number, meaning it's only divisible by 2 and itself. 8 is also divisible by 4, but 4 does not divide into 2 evenly. Now, let's move on to number 2. What is the GCF for 6 and 16? So remember, the factors for 6 are 1, 2, 3, and 6. The factors for 16 are 1, 2, 4, 8, and 16. So the largest one that they have in common is 2. The greatest common factor for 12 and 20, well, that number would be 4. 2 is also a common factor, but it's not the largest one or the greatest one. So GCF is 4. Now we move on here to number 4. This time we have 3 numbers. What is the GCF for 10, 15, and 20? That GCF is 5. Number 5, what is the GCF for 16, 24, and 40? That GCF is 8. All right, so when we're talking about the greatest common factor of a polynomial, that is going to be the product of the GCF of the coefficients, so that's why we practice numbers in the above examples, and the variables they have in common raised to the lowest exponent. So product means that this GCF of the coefficients and the variables they have in common raised to the lowest exponent have to be multiplied. That's what product means, multiply expressions together. All right, so let's look at some examples of identifying the GCF of variable expressions. So here, number 1, I have 4x squared y and 6xy squared. So if I follow the two elements that I mentioned above, the GCF of the numbers 4 and 6 is 2, and they have x's in common. X raised to the lowest exponent is just x, seen here, and y is also in common. Raised to the lowest exponent is y, seen here. So your GCF is 2 times x times y. All right, let's move on to another example. So here I have 12 a cubed b to the second, 20 a squared b. All right, so my GCF, the greatest common factor for 12 and 20 is 4. They have a's in common. The a raised to the lowest exponent is a squared. They also have b in common. Raised to the lowest exponent is just b. So your GCF is 4a squared b. Right, here's another example. 6r squared t and 9r squared s. All right, let's talk about the coefficients first. The GCF for 6 and 9 is 3. They have r's in common. Raised to the lowest exponent is just r. They have s in common. Raised to the lowest exponent is just s. They do not have t in common, therefore that is not part of the GCF. So your GCF is 3 times r times s. So they don't just have to be monomials. I'll do one more example right here. You could be asked to find the GCF of, let's say, 5x plus 2 to the fourth and 10x plus 2 to the third power. So you can still identify the GCF in the same way. The GCF for 5 and 10 is 5. They have a common binomial of x plus 2, but raised to the lowest exponent would be x plus 2 to the third. Okay, So now that we understand how to identify the GCF for variable expressions, we can use that information to factor polynomials. Factoring a polynomial means to rewrite it as a product of expressions. So there's that word again, product. So when you have a polynomial written with different terms being added or subtracted together, when you factor it, it means that you then write that polynomial as a product of expressions. One expression times another. Could be just two products, or there could be multiple. All right, so here's our first example. We want to factor 2x cubed y minus 4x squared y plus 12xy. So that is a trinomial, and so now I want to rewrite it as a product. So you can think of this as the opposite of the distributive property. We're going backwards from the work we did in chapter 10. So those three terms, 2x cubed y and the 4x squared y and the 12xy, they have a GCF of 2xy. So that goes in front of the parentheses. And then what's written inside the parentheses is what's needed in order for it to look like what's above. So in other words, 2xy times what will give you 2x cubed y? Well, that's x squared. And then 2xy times what will give you 4x squared y. And so that answer is minus 2x. Make sure the signs match up. And 2xy times what will give you 12xy. Well, there we need a 6. So you can always check your work by multiplying. So if you were to take your answer, the product that you wrote here that's in this box, and multiply it out, it should equal what you started with. So that's always a good check. You can do that mentally in your mind. So here's another one. We have 3a squared b squared plus 9a squared b minus 15a squared. The GCF is 3a squared. So they don't all have a b in common, but they do have an a squared in common, and the GCF of 3, 9, and 15 is just 3. So the 3a squared gets written at the beginning, and then inside the parentheses, you write what's needed in order to look like what's above. So 3a squared times b squared plus 3b minus 5b is your answer. Okay, here's one more. I have 20x cubed y minus 25xy plus 10yz cubed. The GCF is 5y. They do not all have x's in common. They do not all have z's in common. So the GCF is just 5y. So inside the parentheses, you are left with 4x cubed because 5y times 4x cubed gives you your first term. Second term is 5x because 5y times minus 5x gives me negative 25xy. And the third one is 2z cubed because 5y times 2z cubed gives me 10yz cubed. Okay, so that's the most basic thing you should look for when factoring is look for a GCF, and if it exists, that GCF goes in front of the parentheses, and what's left inside the parentheses is the expression that remains in order for it to equal the previous step. All right, the next technique for factoring is called factoring by grouping. It's actually very similar to what we just discussed. So here we have 2 times x minus y plus a times x minus y. So I basically have two terms, this being term number 1 and this being term number 2. If you look at them, they have a common factor of x minus y. That's the common binomial that they share. You put x minus y in the front as the GCF. And then x minus y times what will give me the first expression? Well, the only thing that's missing here is the 2. So you write a 2. And then plus x minus y times what will give me the second expression? Well, that would be a. So your answer or your factors are x minus y times 2 plus a. That's pretty straightforward. Okay, here's another example. It's really similar. Number 2, I have x times 4a plus b minus 5 times 4a plus b. Just like the last example, these two expressions have a common factor of 4a plus b. That goes first. And then what's left is the x and the minus 5. So that goes second. So what's inside the box is my factored expression because it's written as a product. The original expression has a minus sign in between, so that is not considered to be factored. All right, so usually with factoring by grouping, there'll be a little bit more work to do than what I showed you in examples 1 and 2, and that's more like what you'll see in example 3. When you're factoring by grouping, you should see 4 terms. Oftentimes you will see 4 terms the way you're seeing here in example 3. So when you look at the 4 terms collectively, they do not have a GCF. They don't have anything in common, but they do have something common in common in pairs. So if I look at the first 2, they have a GCF of z, and the second 2 have a GCF of 3. So that's what you see in this first line. I factored out the GCF from each pair. So I'm left with z times 2a minus 5 plus 3 times 2a minus 5. Now, this second line looks like my first 2 examples, where I have 2 expressions being added together with a common factor of 2a minus 5. That goes first. And the expressions that remain goes second as the second factor. So 2a minus 5 times z plus 3 are the factors of the original polynomial. You can check it by foiling the answer, and you should get back to where we started. All right, let's do one more like that. Again, here are 4 terms: 2ax minus 6x plus ay minus 3y. Again, looking at them collectively, all 4 of them do not have a common factor, but in pairs they do. So the common factor for 2ax minus 6x is 2x. The second one has a common factor of y. So in the second line, I factored out that GCF from each pair. So you're left with 2x times a minus 3 plus y times a minus 3. So you're not quite done because, again, this is not factored in line 2 because I have a sum in between. So they have a common binomial of a minus 3. You write that first. And then you're left with 2x and plus y. That gets written second. So your answer is a minus 3 times 2x plus y. So if you happen to write it in the other order, this is true for all of the examples we did. 2x plus y times a minus 3 means the same thing. These are equivalent. And that's true for all of the expressions that we factored today. Multiplication is commutative, so the order of how you multiply doesn't matter. Okay, so that's it for this lesson. Give the homework a try.